We physicists have waited 100 years since 1916 for this photograph. It is a region where black holes might just be one of the most fascinating and mysterious phenomena in the universe. They are massive beasts in terms of power but at the same time virtually invisible to us, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun. But because of the research that was put into them over the last couple of decades, we've gone from knowing absolutely nothing about them to getting to learn more and more up close and personal. And while things have just gotten crazier, Michio Kaku just announced that we've finally gotten a look at what's inside a black hole, and this new information brings light to the details the world of science might have missed all along. Join us as we dig deeper into black holes and unveil what's inside space's big bad. What are black holes? Before we get into the details of what Michio Kaku found, we have to talk about the firsts. Even though most of us have some idea what black holes are, there are still some gaps in the right information. You see, in 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. At that time, the concept of black holes was purely theoretical. It took another 50 years for the scientific community to find evidence that black holes actually exist. This happened in the 1960s when they were studying the Cygnus constellation and noticed an oddly bright blue star emitting X-rays. This star wasn't a stagnant object but was going around a giant black something. Upon further investigation, it was found that the X-rays weren't just moving around on their own but were being sucked into the black thing they were orbiting, thus the name black hole. This discovery was significant because it provided proof that black holes actually exist and that they were not just a figment of Albert Einstein's wild imagination. While that was great, it also meant that there was this unreal entity in space that we urgently needed to know more about, so researchers all around the world got to work. This black hole was named Cygnus X1, and it is located in the constellation Cygnus about 6,000 light-years from Earth. It was no small discovery. It's about 14 times brighter than the Sun and incredibly dense, which causes it to have a strong gravitational pull. The gravitational pull is so strong that not even light can escape it. This is why it is called a black hole. The concept of a black hole is both fascinating and terrifying. It is a region of space where gravity is so strong that nothing, not even light, can escape. Anything that gets too close to a black hole will be pulled into it, never to be seen again. But that aspect of danger makes it even more necessary to learn everything there is to know about them. Was this it, or were we just beginning? The answer ended up being the latter. After the discovery of Cygnus X1, scientists started to search for other black holes. They found that there may be close to over 100 million black holes in the Milky Way alone, but because they are so incredibly hard to detect, we still don't have an exact number. Nevertheless, from the looks of it, there are several million black holes in the Milky Way in our very galaxy, which is what makes them even more important to study. So let's break it down. The main concern with black holes is always going to be gravity. Their gravitational pull is so intense that anything that enters it compresses down astronomically until it becomes a singularity. In simpler terms, black holes are like cosmic vacuum cleaners that suck everything in. One of the scariest parts about the research that's gone into black holes is the fact that if someone were to fall into one, they would get stretched to the point that they become a single line. This process would happen slowly, and the person would die before the final form actually sets in. So let's just say that no one should be stepping into one. But they're all over, so could we really be in danger? Despite the fact that the closest black hole to Earth is 1,500 light-years away, it's still close enough to bring up questions and concerns. In 2021, scientists were able to release the first clear photograph of a black hole, specifically the M87 black hole. This black hole was photographed several nights in a row, and with each photograph, the researchers gathered more and more evidence about it. They had to stitch the individual photos together to create something that filled all the gaps. This way, they were able to figure out that there are 3 layers to a black hole. It's not just one single gaping hole of nothingness as many people believe. Things are a lot more complicated than that. To even get to the nothingness part of a black hole, you have to make it through the first 2 layers. The first layer is called the event horizon, which, while in the first layer, is the point of no return. Once you pass the event horizon, there's no turning back, and you will be sucked into the black hole. It only gets worse from there on out. The second layer is the photon sphere, which is the region where light orbits the black hole. Any light that enters this region will be trapped and will not be able to escape the black hole's gravitational pull. Finally, we come to the third layer, which is the singularity. This is where everything that enters the black hole gets compressed down astronomically until it becomes a singularity. The singularity is a point in spacetime where the laws of physics as we know them break down, and we just can't predict what happens next. At the singularity, the density is infinite and the laws of physics as we know them cease to exist. Now, what makes all of this infinitely worse is the fact that every single black hole you study will be entirely different from the last. Sure, they do tend to follow the same three-layer concept, but the way they function could be vastly different. Now, if this were anything else, all we'd need to do is hop back on those telescopes and just study the problem at hand in detail. But with black holes, you can't really do that. Scientists can only study black holes indirectly by observing the radiation they emit and the gas and dust that surrounds them. Sending a probe like the Voyager inside a black hole is not possible because anything that enters the event horizon is pulled towards the singularity, where it is compressed to an infinitely small point. So you can't exactly waste billions of dollars just to get a glimpse every time, because the second the probe gets close enough, it'll just crush into nothingness. Because of that glaring problem, scientists are left with no option but to study these objects in a two-dimensional way, even though they are three-dimensional phenomena in reality. To make matters even more challenging, there are also the two problems of every black hole being unique and the laws of physics as we know them breaking down when we try to explore the inside. This means that the traditional methods of scientific inquiry don't really apply to the study of black holes. That doesn't mean that the researchers haven't been busy. There are lots of different theories and explanations of black holes, and well, with each one, things get more and more interesting. One of the most compelling theories about the formation of black holes is that they are created from collapsed stars. When a star exhausts all of its fuel, it can no longer produce enough energy to counteract the force of gravity that is constantly pulling inward. As a result, the star begins to collapse in on itself, becoming smaller and denser as it does so. If the star is massive enough, this process